Hi everyone, and welcome to the week three session one of our Cairo Bootcamp 5. Last week we went through Starknet's contracts concept, but then this week Wilfred will be diving deep into the advanced contract concept, which he will discuss event threads, syscalls, cross-contract interaction, and libraries and so on. So I would just instead of wasting his time, I'll just let him introduce himself, and then dive deep into advanced contract concepts. By the way, my name is Paul Emmanuel, and have a nice one in the class. Hi, Wilfred, are you there?
Yeah, can, can you see my screen?
Yeah.
All right. I'm in my VS Code window. Okay, before I was it right to go straight to sharing? But before I continue, before I begin, as we heard last week, I'm Wilfred Okori. I'm a software engineer. I write smart contracts in Starknet, and I'm here to take you from zero to hero. After last week, I hope you are no longer in zero. But I'm here to take you to hero of writing Starknet smart contracts.
Please, sorry,
So
can you like share your this code base with us?
yes,
Yeah.
exactly. That's what I'm going to do now. Hold on. Can you still see my screen?
Yeah.
Okay. So where are the comments? So I've just pasted the repository in the comments. So this class is going to be mostly code and less talk. So I would like every one of you to take a minute or two, fork this repository, or you can just clone it directly so that you have it in your local so that we're all going to be coding together. Is that okay?
So,
All right. Um, while I'm waiting for you, I'll be going through my slides because there is no time to waste. You only live once. Okay, so in today's class, I hope everyone can see me. Can you hear me?
yeah.
Hello.
Yeah, we can hear you, man.
So in today's class, we are going to be dealing with events, traits, and interaction in terms of dispatchers and libraries. And then we're going to be looking at composability and components in Starknet. This one just talks about splitting your logic when writing the Starknet smart contracts. So without wasting time, the first section is for events, right? Last week, when we wrote this smart contracts, we talked about events, we emitted some events. So I'm not really going to take much time on this. Before we continue, I'm not going to wait for the minutes. Has anyone successfully cloned the code base?
Yes, I've done that.
All right. Any other person? 2 or 3 people is fine. Dominion, John Bosco. How many points? Stanley, Peter, anyone? Okay, that's very good. So do you have a question? Your hand.
I've cloned the code base. I've cloned the code base.
All right, well done. So when events, as I mentioned last week, are just Starknet's way of showing that, of informing the outside world or whoever is watching that so and so action has been carried out. It can be a new person has registered as a user in this contract. It can be this contract has sent money to another, to a wallet. It can be anything. But you are the one that defines your events, right? So as I said, events are just the way of informing the outside world that an action has been carried out. Events are usually defined in an enum named events where there are different variants that can be emitted at a time. So it's, as we all know about enums, we did it in Cairo Basics last week or 2 weeks ago. I don't really know. But enums, we know that there can be different variants, but just one at a time. So that's the same way we can actually emit different events for a particular action, but one in line. You are going to see it's there, but I'm just going to go to my VS Code. Here we define 4 events: book borrowed, book returned, book added, and book removed. And then we put each of them inside these enum events. If you look at it, it derives the traits drop Starknet events, and then it has this event decorator at top. Now, what I said it's derived traits, right? Events, before I continue, events can be annotated with flat attributes to unwrap them if they are nested. Like when you write a component and that component has its own events, it's best to use this flat so that when it's emitting the event, it's not going to emit it as this component inside this contract. It's just going to emit the event as it is. Like it's going to unwrap all the emit the base events. Then events can also be annotated with the key attributes for special indexing. So they are using whatever library you are using to interact, such as Starknet JS or Starknet Rust, Starknet Py, or anything. You can, these key attributes enables the user to be able to search for events with those keys. So if I come here to put, I can actually come here and write key, and then it's recognized as if I write key here and say I write key here as well, it will mean that I can search for all the time the person with this address borrowed or returned books based on the events as it is key value pairs. So this will be key and it will return this event. So I can make a search that I'm looking for the events book borrowed and book returned, where the key is this person's address. So if the person has borrowed books 10 times and has returned 5 times, it's going to show me each of the times that this person has interacted with library in that way. Do you understand? Is anybody following?
And I'm following.
Okay. So the next thing, okay, this is how events look. Next thing I'm going to be looking at before we look at Syscalls, I believe you must have done it, or I believe you must have done it in Introduction to Cairo. But because of what we are going to do today, I feel I should iterate it again. Now, when you see this derive, copy, drop, cd, and store, what this thing, this, what this is basically code that writes code for us. So you can actually comment this out, and then instead you say that this struct is defined only for types that can be copied, dropped, just like this. So this derive you are saying is just a shorthand to write exactly the same thing. What it means is that each field inside this struct should be able to be copied. That is the requirement for any data structure to live inside this struct. Now, what do I mean? In Cairo, one thing Cairo is optimized for is memory allocation. So these primitive data types like U8, felt 252, and even contract address was under the hood is actually a felt. And then this boolean, they can easily be copied. It doesn't cost much to store them. It doesn't cost like too much memory to store them. So they can easily be copied and used elsewhere. But there are some other data structures like an array, for example. An array is actually quite memory heavy, so it cannot be copied. Instead, it's going to be cloned. A very good example would be a byte array. So I'm going to add a field to this struct to demonstrate that. I'm going to say this field is a description. Remember that a felt is like a string. It's like a string representation in Cairo. You can use it for things you use string to do, but it can only contain 31 characters, right? Now, in some cases, you might need more than 31 characters to store a particular data. In this case, the best thing to use is a byte array. And a byte array, I don't know if I'm going too deep, but the difference is that each of these data structures, their size is known at compile time. But for things like array, they can have any number of elements in them. For a byte array can be as long as anything. So Starknet doesn't store it on the stack. Sorry, Cairo doesn't store it on the stack. It stores it in the heap. So where data is stored determines whether it can be copied or whether it cannot be copied. So back to I was talking about the byte array. A byte array's size is not known at compile time. So if I try to put a byte array within this, what have I done? You can see that it's giving me an error. Can you see it? Is anyone following?
Yes, we're following.
Please be sure you are following because it's going to be very important in writing a contract. You can I put byte array inside here. A byte array can't implement the trait, it can't implement the copy traits because its size is not known at compile time. So if I want to use a byte array more than once, I'm going to have to make a deep copy or clone. So a byte array can implement clone. We can see that the error is now gone. I mean, the error is not gone for this case because I'm going to have to manually write whatever. But that's the point I'm making. Traits here what traits do for us is that traits restricts the kind of data we can put inside structs or enums. So if a particular data type cannot be copied, we can't put it inside a struct that derives the copy traits. If it cannot be dropped, we can't put it inside a struct that derives the drop traits. Am I communicating? So one of the things you are probably going to experience a lot is with this byte array and the fact that it cannot be copied. So I'll come back here and then I'll implement the copy trait again. And everything is back to normal. So this
Sorry to cut
thing
you
of
short. Sorry to cut you short. You said bytes array, they cannot be copied.
yes,
But if you want to duplicate them, you use that clone
clone.
bar.
Yes.
All right.
Okay, let me just demonstrate it. Say let's random byte array. A byte array is written with two a double apostrophe like this. So random byte array. It still needs type annotation. So I'm going to call it a byte array. Right? Now, if I'm going to use up this byte array to do anything. So let's random is equal to random byte array dot at 0. Let me put it that way. Dot unwrap. Now I've used up this byte array. If I want to use it again, let another use equal to random byte array dot at 1 dot 1. Okay, indexing is not really consumption. What am I going to do now? Okay, see, there's no time, but in essence, the thing is that in most cases, for example, when you pass this to a function to do something with it, I can actually write a function used by so this is still under ownership. By um, it's giving me an error. It says that this has been previously moved. That's how data structures are stored in the heap work. So if I want to use it more than once, I'm going to have to say clone. Do you understand? Did anybody follow what just happened?
No, sir, I didn't get that part.
Okay. So this is going to be important traits when we are writing components. But for now, let's move on. So the next thing is Syscalls. In Starknet, Syscalls are like low-level calls to the Starknet virtual machine. Now, the Starknet VM is basically a computer that we can interact with. Now, when you are interacting with this computer, you are either creating a file and you are doing things within that file or within the address that you're interacting with. But in some cases, you want the Starknet VM, the Starknet computer, to help you do some things that are not actually within the jurisdiction of a contract. A good example is emitting events, right? You actually don't have the power to emit events from your contract. That self.emit is actually wrapping a syscall called emit events. It's a system call. It's telling the Starknet OS to help us inform the outside world. It's not the contract informing the outside world by itself. In the same way, there are different syscalls that can be used. There is the deploy syscall, where you actually pass a class hash, and from one contract, you deploy another contract. There is a call contract syscall, like from within one contract, you can tell the Starknet OS, okay, get this data from me from this other contract that is not me, and it can actually do it for you. You can get execution info. For example, you want to know the person that is calling this function, right? Because normally in bare Cairo, you don't have any business with who is calling the function at runtime. But because of the syscalls that we can make to Starknet, we can now actually get things like the block hash, the block number, where this particular transaction is executed. Do you understand? Is anybody following? It's not your contract that has the right to do it. Instead, it's making calls to the Starknet OS to perform this action on its behalf. Now, some of these syscalls actually wrap functions that we use almost every day. For example, when we emit events, we use self.emit whatever event we're emitting. Under the hood, that is actually a wrapper to this emit event syscall. When we say get caller address, that is actually a wrapper to this get execution info. Get execution info returns different data. It returns both the caller address, the block timestamp, the block number. So saying get caller address is actually wrapping this. Do you understand? I kept the sorry, a minute. Let me just show you. I think I've lost it. But you can actually go to the Cape Starknet Strange GitHub to see what each of these syscalls have to offer. But in our code, because I'm just going through these slides fast, what we are going to be doing is that we are going to be implementing everything inside the contract, because nobody wants to see all talk and no do. Then the next thing we are going to talk about is components. Before I move on, any question about syscalls? Any? No. Very good. The next thing we're going to be looking at is components. There are also cases where you might be writing a smart contract, and if you write all the functions that are going to be in this smart contract, you end up having a file of say 6,000 lines. Sometimes you don't want that. There are also other times where you see that, okay, say our library contract now, is not free to everybody. Instead, each person has to register before they actually have access to books inside our library. So things that concern user registration, things like a register user function, a blacklist user if we don't want the user to be able to borrow again, a permit user, different things that concern a user interacting with our library. We can actually separate all those functionality from the rest of the contract and put inside the components. Then we'll use the components within that contract. Am I communicating? If you then like if there's anything you don't understand, please like speak up. If you write something like React, or I think that's a very good example. If you write React, you know that there are sometimes, say you have this button you created and you want to use the same logic for every single button in your front end. You can write a reusable button component and then just render it wherever you want to use it. Components sort of work that way in smart contracts. You write a single component and you are able to use its logic inside the smart contract. So as the slide says, in some cases you want to completely separate concerns in writing code. In some cases you want to have logic that you can use in different places. Components are like Lego blocks, exactly. They act as pluggables, so you can just plug them into your smart contracts, and it's going to provide this whole set of functionality for you. Now, components are very similar to contracts. A component has its own storage. Steve, can you mute your mic? Okay. A component is very similar to a contract. A component has its own storage, emits its own events, and has internal and external functions. So I think this is where we are going to be starting our code. So open your VS Code and let us cook. Is everybody following? Any questions so far? Very good. I'm going to organize this code base differently. All of this logic here, I'm going to put it inside the contract. I'll call it library.cairo, right? And then I'll call this one access control. No, access control is too cliche. I'll call this one user registration components. User registration component dot Cairo. So this logic you can see here, I'm going to cut it and paste it here. And then I'll come to the lead.cairo. Sorry, you have asked me a question. I'm going to make this public so that I can access it from there. So pub mode, contract, within contracts, pub mode, library, so that my compiler can now see into this file. And I'll actually do the same thing here. Pub mode components. What I just did here is that when I open curly braces like this, it means that I've opened the folder. When I put a terminal semicolon like this, it means that I'm referring to a file. So it's just that simple. So I'll call this pub mode user registration component. Any question? So the compiler can now actually see into this file as well. So the first thing I'm going to do is I'm going to define my interface. I register C. Okay, let me use the T contract state again. So the first thing is for register, sorry, function register user. And this one modifies states. So I'm going to be calling the self by reference. And what I'm just going to take user name, which is going to be a felt. I'm going to take the user last name, which is also going to be a felt. And that is it. Please, if you can, try to follow so that we are going to be doing the same thing. And I don't want to be caught in a case where it works on my machine. I want it to work in everybody's machine here. So any error you have, please actively share it in the class. This is a coding session, it's not just talking class. But is everyone following me so far? These are those. Cool. And I'll take in, okay, this is a read function. So I'm going to pass it by snapshots.
Oh my God.
User ID. The user ID is
I
going
didn't
to
follow my
be,
Bluetooth.
sorry,
Ah.
blacklist user. This is going to modify states. And this is also just going to take user ID. Um, and what else? I think that's it. I had other functions in mind. Let's start with this. So the next thing, can you hear me? Can everyone hear me? Your reactions. Those are what I'm saying.
Yes.
All right. The next thing that I want to do is we have written an interface, so we want to write the component proper. If it was a contract we're writing, just like you can see here, we annotated it, we did Starknet, what is it? Okay, sorry, Starknet contracts. So here, what we are going to do is Starknet components. So I'll format registry component, and it's shouting at me. It says it must have a storage struct. So I'll give it the storage struct it wants. So what I start, I'm just going to import the storage details that I need. I'm going to import map, storage pointer, read access, storage pointer, write access, storage path entry. And I want to use a vec here. I don't know what I'm going to use for yet. We are going to use a vec. So the first thing I'm going to do is, okay, before I come, let's also define events. It's, as I said, the component looks almost identical to the contract. I'll derive drop and Starknet event, and then I'll define some structs for the events I want to, sorry, for the events that I want to implement. Same thing. user registered, and the user is going to be a contract address.
Hi, Wilfred, are you there?
I was thinking it was on my end.
Oh, I think maybe his network like tripped off.
Can you hear me?
Yeah, we can hear you now.
Yeah,
It
yeah,
seems like your
Okay.
network.
Network.
yeah, the network.
So I'm going to pay. Can you see my screen?
Yeah.
Can't see your screen.
Okay, beautiful. Right. So I can work with. So user registered and user blacklisted. Then I'm also going to implement a user struct. I'm going to create a user struct. So struct user. I'm going to use the ID. You know what? I'm not going to use the address. Um, let's leave it at this for now. What I want to achieve before we continue, I'll tell you what I want to achieve with these components. In the library, we remember that anybody can just actually come into the library, borrow a book, and return it at any time. Now, we don't want that to be the case. We want to actually regulate how much each person can borrow a book. So, what I'm going to do is, after I register each user, I want to allocate each user a specific number of tokens. The token is going to come from a component. I'm going to use a component, which is part of the class, right? I'm going to allocate the user a number of tokens. Now, these tokens represent the quantity of books each user can borrow. So if you have used up all your tokens, you cannot borrow, you cannot, what's it called? You cannot borrow more books until you return some of the books that you have. Do you understand? Am I making any sense? So that way, depending on the importance of the book, you can't be with two very important books at the same time. So in order to do this, I'll come back to my library here. Okay, one more thing. Okay, let me make it just a file. I'm going to say types.cairo. I'll come to my lib.cairo and say public types. Now, uh, I'm going to cut this away I'll put it here in types. Same way, I'm also going to cut this away. Any enum and besides events, because I don't have the energy to copy and paste all my events here. But any enum, any custom enum or struct that I define is going to be within this type of Cairo. That's what I want to achieve with it. So use Starknet, contract address, right? And everything is fine again. So I'll come here, use create types and book. The compiler is still improving, but this should be okay now. Unless my WSL is about to panic. How can I do? This should be okay now. Sorry, I'm just going to wait. Oh, one more thing. I have to make the fields public also, so that they can be accessed from where they are. I'm also going to do this. Then the next thing I'll do is what was the layout? That's it. The next thing I'll do is I'm going to use an ERC20 component for the tokens so that it will give me the ability to just check the user balance and do whatever I'm going to do. Before that, I'm going to have to add a, I'll call it a weight to each book. This weight, now what this weight represents is the number of tokens a person has to have in order to be able to borrow them. Am I communicating? So here I'm going to add the unit 5.6. I'm also going to add it here to the unit 5.6 and put it here. So that this is all right. Next, I'm going to add an ERC20 component. Now this leads us to another topic, libraries. Can this thing give me? Now let's look at our scap.tml. In our scap.tml, you can see this place called dependencies, right? These dependencies are the libraries that we intend using while building this contract. Of course, this is Starknet smart contracts. So Starknet has to be one of them. But one thing, I'm going to use a library now that provides reusable components called OpenZeppelin. So there are two ways to add libraries to your code base. You can either say scarp at OpenZeppelin at 2.0.0. This is going to work. This is supposed to work. Okay, and that's added it now. So what's happening? Why can't I see? Oh,
The file is not saved, so you kind of like close it and reopen.
okay. Okay, exactly. It's added now. I had a bad feeling my WSA is about to panic. It's going to happen anyway. So I've added open Zeppelin. What I'm going to do now is I'm going to open Zeppelin. Remember that what we're writing is a component. Okay. So I choose a map. The map is a country.
Hi, Wilfred, are you there?
I think the service is off again.
Yeah, that's sad. Let me just try and chat to him.
Again, my network froze me out. It's actually very unstable here. Can you see my screen again? You can see my screen again, right?
Yes,
Not
we can.
Alright. So let me just get rid of this. Because I actually don't like seeing this. Okay. So the next thing is this is actually very important. The impel, and I'll call it registry components impel of I what's happening. Um sorry. Oh, Yes, so back to our business. In the smart contract, above our Impel declaration, we put ABI embed V0, right? In this case, that's not what we are going to use. Instead, can you hear me? Can anyone hear me?
Yes, we can hear you.
All right.
Yes.
Yes, I can hear
Okay, okay. So this is how we are going to put it. Because as mentioned here, um, components, the principal difference between a component and a contract is that a component cannot be deployed, while a contract can be deployed. Do you understand? A component can only be used within a contract. A component is not independent, can't run on its own on the Starknet network, while a smart contract can. So because it can be deployed, one thing that a contract has that a component does not have is the constructor. Why? Because the constructor is a function that runs at deploy time. So since the component cannot be deployed, it does not have a constructor. And then we can't state that we are embedding it into any API straight away. Instead, we can only embed it into contracts. We can only embed components into contracts. So instead of saying ABI embed V0, what we're going to say is embeddable as registry component info. So that anywhere we're using it, we are anywhere we're using it, we will call it with this name. Then the next thing is that because of this thing right here, because of this Starknet contract that you're seeing here, this Impel had access to contract states. But then ours is not Starknet contract, it's a Starknet component. So what we have access to is not contract states, it's component states. Am I making any sense? That's one. And then, okay, we have not imported within super high registry. Then, okay, let's take a look at the Cairo book. The Impel block is different from what we see in contracts, right? In a smart contract, this doesn't need to have a type. This doesn't need to have type trait bounds, but this must have type trait bounds. So the bound that is going to be here is T contract states, then plus has components T contract states. Am I right? Yes. I'm going to, it's complaining that it's defined multiple times, so I'm going to change this one to registering supposed to get rid of that get rid of that error. So this is saying that I have not implemented the traits elements here. So I'm going to do just that. And another thing here, we had in the functions, we had contract states, but that's not the type that we have here. The type that we have here is component states, wrapping contract states. So I'm going to change all of this. component states, wrapping, C contract states. And yes, that is it. Then to register user, okay. Yeah, that's what was left. Is anybody following me? Is anybody still with us? Have I lost anybody? I expect questions because this thing bugged me for weeks when I was learning Cairo. Nobody has any question. Ah, Jesus Christ, this student is smart. When I go be like, no. Anyway, what we are going to do next is, what are we going to do next? Okay, things I wanted to add to the user strokes. I wanted to add, what's it called? I wanted to add first name and last name. Let's suffice. And I actually forgot to derive traits here. I'll derive copy, draw, CD, and store. So the first name is a felt. The last name is also a felt. And for now, total weight. The total weight is the the total weight is a numeric expression of what the user can borrow, and then the used weight is what the user has currently borrowed. I'm going to eventually change this to proper ERC20 tokens. But for now, I'm just going to keep track of it this way. So to register a user, first of all, I'll say let user equal to get caller address. And I need to import this up here. Get caller address. So let user address. So to get caller address. Good. Let me add something to this storage. Yeah, using it. Okay. Sorry. User count. I'm going to be a simple UX. And user ID equal to self dot user count dot reach plus 1. So initially, the user ID is going to be 0. But when I increment it, so initially the user count is going to be 0. But when I increment it, the first user ID has to be 1. I don't want 0 indexed. And what else is there? Okay. Let's user equal to user. What is the user missing? The ID is user ID. What else? Address is user address. The first name is the user first name. I've just used identical as the user. Exactly. This brings me to another storage variable. Another thing is that I want to have control of the tokens I can assign any user. So say when I start the library, I'm only assigning each user 20, a weight of 20. I want to be able to adjust it. So I'll say user weights. It can just be a simple unit as well. So total weights, self dot user weights dot read, and then use weights is 0 because the user has not borrowed any book. What's happening here? What is happening here? Oh, oh. We expect a U256. Let me change this. So self dot users dot entry user ID dot start user. Hmm. And I'll also change this. Then finally I'll emit an event self dot emit user registered. What does it need again? Timestamp, and I'll get block timestamp. Okay, I have to import this function up here. Yeah. Sorry, hold on. Oh, okay. I'll leave it as contract terms. What I'll just do here is we have not put this event inside here. That's why it can't emit for now. So I'm going to have to add them. User registered. I mean, user blacklisted. User blacklisted. So what else is there? What was really happening? I'll get to the bottom of it. But the next thing is to implement this function. Self dots. It really doesn't make much sense. Wait, what did I do wrong? Oh, that's it. Oh, that's correct. Before I continue, um, no, okay. Sorry, I'm just going to change this now. Contract address. And it's going to map addresses to users now. User. So what I'll just do here is let user address go to get caller address. And then I'll use the user address to get this. I'm going to have to remove this. So it's just going to be the key. It's not going to be parts. So, so I'll say if user is equal to default, I'll return false. Else, I'll return true. So what I did here is that I where is it right? What I did here is that I derived defaults for this user type so that each field inside here will be filled with zero if the user does not exist. That's why I added this. And now I'm going to add partial EQ so that we can be able to compare two values. That's why this was given an error before. So I'll get the caller address as the user address. I'll use it to check the map, and if the user is default, the registered. Then okay, well, I'm not going to put blacklist user for now. The next thing is that these storage variables here, we have actually not initialized them. In this case, this thing leave me. In this case, there is a constructor. So we're actually able to initialize the storage variables. So what we do in components is that you write internal functions. And most of the time, we don't write special traits for these internal functions. So internal functions or internal traits. In order to make a contract generate it, just put generate traits. So function initializer. Exactly. Anyway, then user with it's the U256, right? And then user count. Okay, I don't need to pass in user count. So I'm just going to write in storage. Self.user count dot write. I write 0 to it. And self.user weight dot write. I write user weight to it. So the thing about internal functions is that they can run before we they don't need to run in the context of this particular impel. That's what I'm saying. I'm going to check what's on it. So sorry. Let's just oh, this is it. They should actually have the same thing. So key contrast to the house and all right. So we can these internal functions are not called within the context of this impel. Like they are different blocks. So before I start using the components to initialize the variables, it's best to call an internal functions to write this component storage. That's how we use components. So I want to use this within the library contract. So I've not implemented the blacklist function, but I think I'll leave that one for you. So I'm going to say use create components and this in registry components. How is this? So to initialize, I'm going to say components. The database is about to show. Sorry, hold on. So in order to set up a component, I'm supposed to have path, which points registry component, event, I'll call it registry event, and storage. I'll call it registry. This is supposed to be giving me some errors now. So in my storage, what I have to do is storage. Sorry. Since the component storage, we are going to use sub storage and V0 because we are embedding the component inside the contract. So it's not a base storage, it's a sub storage. So I'll say registry, and it's going to be registry component storage. I'll do the same thing here with events. I'll say flat this time, and registry events is going to be registry component dot events. And then the last thing I'll do right before this info, actually not the last, I'll say registry implementation is equal to registry component registry info and contract is equal. If I also the then registry internal info is equal to registry components oh it's not the contract. What happened? Okay, it was just the order. So I fixed that. So what I've done here now is that I brought this component into this context so that whatever functionality we have here, whatever functionality was inside here, we can access it from inside this. And then the simple things I just did is I collected the impulse. So both the internal implementation and the embeddable as. So I'm going to come to this constructor inside my Can you see my screen? Can anyone see my screen? No one? Can you hear me?
Yes, we can see your screen and we can hear you.
All right. So, in order to be able to call the functionality, I'm going to use all we have to use is the storage, this registry. So I'm going to say self dot registry because that's what stores the components and then dot initializer user weights. So this way, when the library is deployed, the component is also initialized with the user weights. In the same way, whenever a person wants to borrow book, I can easily come here and say net is registered be equal to self dot registry dot is user registered, and then the ID is an address because that's what we're using. Is that what we're using? Okay, we actually don't need the ID anymore because I just use the color direct. So I'm also going to remove this because it's going to be the same color. So I can say that a person cannot borrow a book. It's registered. And I'll put an error message. User not registered. So any user that is trying to borrow a book that is not registered in this library is not going to be able to. I know that this component is a sensitive topic. So any question before I continue? Do I have to go back any place at all? Can we continue? Oh, Peter, you asked why weight is stored in storage. I said I don't want to initialize. I don't want to initialize the ARC20 yet. I wanted us to see how components are implemented from top to bottom. But now that we have completed that one, let's use a component instead. So I actually don't have use for these things for now. When I do, I'm going to. But what the vec is used, the vec is just a list. It's like an array. So what I'm going to do is I'm going to use Open Zeppelin tokens. So use Open Zeppelin. Open Zeppelin provides us different utils for access control, accounts, finance, different things. So I'm going to use the token. I'll use ARC20 components. So I'm going to embed the component within another component. Before I do it, let me come here and see. Can it actually work like this? Um, one is going to have to start it. So, why is this one doing like this? Okay, I don't think this is actually possible. Um, for now, I'm going to leave it like this. So just one more function. Get user available with going to return it. Okay. Use Starknet contract address. And I'll come in. So let user is it equal to self with users dot entry address dot read. So what I'm going to read is user um user dot total weight minus user dot used weight. That's what I'm going to return. And the last function I'll write, we're actually running out of time, is use weights. So I'll call this one whenever the user is trying to borrow a book. Call this whenever the user is trying to borrow a book. So, no, and I have to pass the weights that I'm using. So let's user import self.users dot entry address dot reach and this is going to be mutable because I want to change it. So user dot use weight plus equal to weight. So I'm incrementing what the user has used, and then I'll write it back. Self dot users dot entry address dot write user. I'll add it to do here. It's part of your assignment. So what did I do here? User not registered. Okay. Then also I have to, apart from asserting whether or not the user is registered before they borrow a book, I have to make sure the user's available weight is more than the book weight. If you remember here, I added a weight field. Oh, why? Oh my God. A second. So I'm adding this as to do. So what you are going to do for me is that you are going to assert that the user actually has enough weight to borrow whatever book he's trying to borrow one. And then if he has enough weight, you are going to decrement the weights, like use up weights here. Okay. So the next thing we are going to do, well, I believe everyone understands how components work now, right? Any questions? This is last time. This was the last time network took me out. Can we continue?
Yes. All
All right.
right.
Network is seriously against me this evening. So the next I wanted to do is implement the factory. I want to I want to I want to create a contract that creates library contracts that deploys libraries. There are two things I want to do with it. I want to show us cross-contract interaction, and I want to show us how to use Syscalls. So, this is not going to be much. The, the internet is still unstable. Oh, wow. Wait, am I sharing my screen? I'm not sure. Collins, you have something to say? All right. This is going to argument is going to take in are the arguments the constructor takes in here. So librarian and user with librarian contract reference and user with beauty class. So problems. Starknet contracts. It has a storage. And this is going to show us the libraries that this is just going to be a list of the libraries that have been deployed. I'll also define an event. It's going to derive job starting the same thing. And say library deployed, library is going to be contract address, and timestamp is going to be used for, right? So I'll come here, library deployed, library perfect. ABI embed B0. iFactory, and the type I'm passing to it is contract, and it has just one function. which says to deploy library. So in this case, we are going to be using a deploy syscall. So I'm going to fetch that. Okay. Let me start from this. Okay, and then I'll store the library class hash. It's going to be a class. Oh, so what does it need? It expects 4 arguments. It deploys this call. As I said, it's making a call to the general Starknet computer. It expects forms, the class hash, address sort, call data, and whether it should deploy from 0 or not. And it returns what's it called? It returns a result. And this result is a wrapper, right? So what we are going to do is, okay, let's pass in all of this. First of all, let's library class hash be equal to cell dots library class hash dot read, right? Next thing is, oh, sorry, I have not implemented this. I also need storage pointer read access and storage pointer write access. Then I also need vectrates, immutable vectrates. So this is the class hash. Let's move constructor call it because I'll initialize an empty array. Then the next thing I want to do in this contract, the constructor needs to what's it called? Arguments, the contract address and the user width. And I got 2 of them from here, right? So I'm just going to say the librarian dot serialize, and I'll pass in the constructor called data. What this serialize does is that it changes whatever data structure you have here. It changes it to a felt so that it can be used by the system to call whatever function you want to call. Because everything in Starknet VM exists as a felt 250. So the same way I'm going to say user weight dot serialize constructor called array. Can anybody hear me? Yes, you can hear me. Next thing, has these arguments in, which are the class hash, the library class hash. What else is needed? The contract address source. I'm just going to pass in one. The call data, constructor call data dot form. and deploy from 0, which is going to be false. I'll call this deploy result. So once I've called this, it has already deployed the contract for me. So I'll now say let library, that's the new library that I've deployed, be deploy results dot unwrap syscall. Okay, I'll change this. Let library address, and I'm not using the other one. So now, then after I've gotten the address, I'm going to write it to the storage, to this storage. So self dot libraries dot push library address. So how a storage vector works is that a storage vector works like an array. It's basically a list. It's just a list. So what I used vec here just to highlight this. Probably if you are ever doing something like this, you should use a map or any other data structure that helps you do key value pairing. But I don't want to do it because I'm not really interested. Next thing I'm going to do is self dot emit. I'll emit an event that I've deployed the library deployed, and the library with the library address, and the timestamp is get block timestamp. So I'm just going to get this here. So this is how syscalls are used. When you use syscall, it will always give you a result like this because it can either be okay or error. So if it fails here, the transaction is going to revert no matter what. That's number one thing. And then when you want to get the result of, like when you want to get the value, always use unwrap syscall. There are many other syscalls. There is the call contract syscall. There are many others. There is emit events. And most of these syscalls now wrap some functions we use. Like this self.emit, I've mentioned this in the beginning. It wraps the emit syscall. So what you are actually doing is that you are calling that system, you are doing that, you are performing that system call. The next thing I'm going to do is okay, I'll just add closed libraries. Okay, contract address. So close library. What I'm trying to do here is that I'm trying to give a library the ability to close itself, just so that I'm going to call it from here, so that you understand how cross-country interaction works. I think this is the last thing we should do. I'm very, very sorry about the network. Contract state. To self dot close libraries dot push. I'll just do a simple push. So about cross-contract interaction, This whenever we write interfaces like this, I mentioned in the previous class that one advantage of writing interface is for the sake of shared behavior, for the sake of reusing functions. Whenever we write interfaces like this and annotate it with Starknet interface, the compiler automatically generates dispatchers for us. Now, what a dispatcher does is that a dispatcher helps you to call the function of another contract from within your own contract. So I'm going to use this factory. I'm going to use this function, close library, within this factory, right? That's what I'm going to do. So first of all, I'll save the factory. I'll store the factory address. Factory. The factory is contract address. And then I'll import the dispatcher for the factory. So use create contracts factory. It has, look at it, it has generated different things. Factory, save dispatcher, subpointers, traits, save library dispatcher, a whole lot of different utilities that we can use. So what we're interested in here is the dispatcher and dispatcher traits. So I'll add one more function here. Function close down library. It can only be called by the owner of the library. I'll put that as the last thing here. Oh, what have I done? Ref states. So what I want to do here is now is that I want to add the address of this current contract, this library, into these closed libraries in another contract using this function. So I'm just going to say let library address, that's the address of the current contract where I'm located, be equal to get contract address. This is another, you should notice that this is another syscall at work. Just like get caller address, it reads the state, it gets the state from the Starknet own, not from within itself. So get contract address, it reads the address of itself at this time. So let library address be equal to get contract address. And then let factory dispatcher now be factory dispatcher. And then I'll pass in a contract address. Self.factory.read. With this factory dispatcher, I can now call whatever function I want to call. So I'm now going to say factory dispatcher dot close library, and I'm closing this current library where I am. So this for any library that is out of business, nobody wants again to close down itself. So, sorry. Paul, can you hear me? I just want to have extra 10 minutes. That's all. I hope everyone is still here. I want to demonstrate all we have done now. I just realized I should have been demonstrating it because I've just been writing and writing and writing. So what I'm going to do is I'm going to build my contract. Uh, does it have to waste my time? My stupid login, my login is what I'm going to do now is that for speed of interaction, I'm going to use AMP. I'm not going to use SNCast. This is a VS Code extension that you can install. It was actually built by me, so you can use it to deploy test nets and manually test whatever you're doing. What's happening here? Let's close this. Last time. So the summary of what we have done here is, first of all, we implemented these components, right? We created this registry component for the library so that you cannot just borrow books like that. And then we use the components within the library. We use some of its functions, while some I left it. You are going to do one as part of your assignment. And then we created the factory to deploy different libraries. So let's build this. Okay. In my Scaffold, I'm going to have a report as AmpNet. And I'll just let open it here, and you can see that it's showing my two contracts. So what I'm interested in first is the factory contract. Okay, in fact, this is the factory contract. It shows us the contract has just two functions, right? And it displays them to us. While this is the library, if you look at the library closely, you can see these functions that are inside here. Everything in this interface, you can see it here. The add book, remove book, borrow book, all of them. You can see it here. But another thing you can see is these functions that are here. Register user, is user registered, blacklist user. You can also see them here. I understand. Is anybody following what I'm saying? The reason you can see them here is that we embedded that component within this contract. Am I making any sense? Hello, can anyone hear me?
You are. Sorry, what's the name of the extension? ANK, ANKH, ba?
Yes, ANKH. Yes. Oh, there is something I did not do. Very clumsy mistake. Um, so sell the library class hash dot write library class hash. And that is when I'll need my storage pointer write access. So I'm going to rebuild. And I'll just refresh this. I'll refresh whatever is here. And then I'll open it. Okay. We can see that, okay, it now asks for library class hash. So let me just go ahead and deploy this library. I'll deploy an instance of this library. I'll just say user weight is 10. Deploy it. In order to get these values here, you have to set it up. Well, the README, like you say, your VS Code is very self-explanatory. If there's any question you have, of course, you can reach out because I'm the maker myself. So, there's an issue here. Oh my God. So there's something we are trying to do in this slide about. Okay. No, I'm not going to stop it this evening. I've kept it for too long. The network ruined out. My sincerest apologies. But we're able to look at how to implement components and how to call functionality of one contract inside another. In this case, we used a function from the factory. This particular function, we're able to use this closed library function within the library contract. And then we looked at Syscalls and we looked at events. The only thing that I did not do in front of you is using a component from OpenZeppelin. And in this place, I had already imported one, but there was no time to go forward with that. So I'm going to, can anyone hear me? Am I? Can you hear me?
Yes, we can hear you.
Yeah.
Okay, so I'm going to fix this and leave the to-dos in the repository. And then you are going to update what you have locally and then complete the tasks that I left for you. Do you understand? Okay, the link to the repo. Uh, and then when you are submitting, all you need to do is submit a link to your fork of this repository. Is that clear? Any other question? Any other question? Okay. So I assume that brings us to the end of class. Again, my sincerest apologies for the network glitches.
Yeah,
This
no.
place is seriously suffering a blow. I'm going to update what I need to update and I'll communicate via the group. Thank you very much for participating in this class.
Yeah, thank you so much, Wilfred. I mean, you did an amazing job, and I'm sure that like a lot of people here also followed with the class, even though there was little bridge of network, but it was still good. So our bootcamp continues this Thursday, and we'll have Oshoke come talk about connecting smart contracts to front end. So Thursday is going to be more front end, and also it's going to be about like Starknet React, Starknet JS, and so on. So you should come prepared for it because it's going to be very valuable for people that want to participate in the hackathon. I'm actually looking forward to hackathon because it's actually a good way to solidify your skill. And since it's not a solo, it's not a must that you must be solo on the hackathon. So it basically means that a group of three persons, as the case maybe, can join their heads together and build out something and hope for the best to win a prize at the end of the day. That aside, please, if you have not submitted the assessment yet, kindly submit it so we can have better evaluation of this bootcamp at the end. And yeah, so the assessment for this particular session and week would be sent on Friday, right? That's it for today. Good night, guys, and see you on Thursday.